Okay, so I know I had to stop that really fast, but this is the homework assignment on law of cosines, and this is homework number 100. And it's in your workbook again, couple of questions just to practice the concept, okay? Alright, so the next thing that we're going to talk about, if you take a look at your reference sheet again, we just did law of cosines, which is awesome because it's right there so you don't have to memorize it. Now what we're going to look at is the area of a triangle, which is right next to it on your reference sheet. So what you're probably thinking is, I already know how to find the area of a triangle. Area of a triangle is 1/2 base times height. I learned that in probably like middle school. Except for the fact that the area of a triangle of like a right triangle like that, was really easy because it was 1/2 base times height. But if you had a triangle like this and you weren't given this height right here, then it was a pain in the butt, and it was always really hard to figure out what the height of that triangle was because you had to use this value for the height, and that was the base. So we are going to learn a new equation for area of a triangle, and the reason why nobody taught you this before was because it involves trig, because it has sine of an angle in it, which is really not hard trig, it's just trig. Okay, so area of a triangle. The area of any kind of triangle is 1/2 the product of any two sides, so A and B, and the sine of the included angle. So that sounds kind of weird, sounds kind of wordy, but let me explain. It's pretty much the same thing as what I just covered before. Let's pretend that this is the triangle ABC. So in this equation, you would use 1/2 little a times little side B, the sine of C. So in order to use this equation, again, forget about the A's and the B's and the C's and where are they in my problem. In order to use this equation, you have to have side, angle, side. Okay? That's the only time that you're allowed to use this, side, angle, side. If a question tells you side, side, and then it's telling you the angle down here, you can't use those to figure out the area. You have to somehow use another piece of information in the triangle to figure out what this angle is equal to, and then you can figure out the area, side, angle, side. Okay? Really not that hard. Literally, this part of the chapter is just plugging numbers in yet again. Okay? So let's try a problem. You need side, angle, side. I already told you that. Okay. Find the area of the triangle. Now, first thing I want to check for is, do I have side, angle, side? Yes, I do. Side, angle, side. Once I have that, this equation is easy. Just plug it in. Just make sure that you're in degree mode instead of radians. The reason why they put a K right here, normally we see area as A is equal to something. The reason why they didn't do that is because capital A in trig normally stands for a vertex of a triangle, like right here. So they just didn't want to get you confused, so they started using K. I don't know. I think that they could have picked a different one, but whatever. So 1/2. A and B are both the legs of the triangle. So 8 times 12. Sine of 30. Now, Miss Tompkins was saying to kids, everybody stop, think about this really quickly before you do it, because we know that sine of 30 is half, so this is really 1/2 of 8 is 4. 4 times 12 is 48. 48 times a half is 24. So K is 24. But at this point, John, honestly, you got enough stuff to worry about. Use your calculator, because personally, I think that it's more important for you to get through this information than to use your head instead of your calculator. So use your calculator. Just type all that stuff in and hit enter. 24. Alright, it's easy as that. Find the exact area of an equilateral triangle whose sides measure 10 units. Okay, let's see. The exact area of an equilateral triangle whose sides measure 10 units. Well, we know in an equilateral triangle all the sides are all the same. Okay, but don't we need an area to figure out, or I'm sorry, an angle to figure out what this equation is for the area? How are we going to figure out what one of those angles is? Well, equilateral triangles not only have equal sides, they also have 3 equal angles. So if all of those angles have to be equal to each other, and we know that there's a total of 180 degrees, 180 divided by 3 equal angles, that means that each of those angles is 60 degrees, and that's all that we needed to know. 60. So K, or the area, is equal to 1/2, and then all we need are 2 of the sides, not 3. Side times the sine of 60. Okay? Now, they're saying exact area of an equilateral triangle, which leads me to believe that if I type this whole thing into my calculator, that it's going to give me a decimal, and that's not what they want. Oops. Yeah, this is going to give me a crazy decimal. And they want an exact value, so that is sine of 60 degrees. Well, sine of 60 degrees is on your magic table. You should either have that in front of you or you should have it memorized by now. Sine of 60 degrees is radical 3/2. Okay? So, let me see here. I have 10 divided by 2, so we can change this into a 5. Another 10 divided by 2, we can change this into a 5. 5 times 5 is 25 radical 3. And just to be careful, just to make sure, I could always do 25 times radical 3, just to make sure that it was the same decimal that I got before. Hit enter, and it is. So that's what they wanted when they said exact. Anytime that you see the words exact on your Regents exam, it's always, always, always talking about the magic table. Okay? Whenever you see that, it's always talking about the magic table. Alright, let's talk about the next question. In triangle ABC, why isn't this moving out of my way? Thank you. Triangle ABC, so let's draw a triangle. And let's label it ABC. Okay. AC is equal to 8. BC is 17. AB is 20. Okay, so this is a two-part question, so let's see what they want us to do. Find the measure of the largest angle to the nearest degree. Find the measure of the largest angle to the nearest degree. So the largest angle is going to be the one that is across from the biggest side. So this must be the largest angle. Now this is a two-part question. The second part wants you to find the area of the triangle. So in this first part, in A, find the measure of the largest angle to the nearest degree. That doesn't have anything to do with area. That actually wants us to use law of cosines. So the first equation that we learned. So we're going to use the law of cosines because we know side, side, side. And when you have all the sides, you can use it to solve a missing angle. So we're going to use the law of cosines to solve for the missing angle. And then we're going to use that angle probably in the area formula to figure out the area of the triangle. So I know that the side that comes first in my equation has to be the one that's across from the angle. So I'm going to write 20 squared is equal to 17 squared plus 8 squared minus 2 times 17 times 18 cosine of C. I'm sorry, 17 times 8 cosine of C. And then, unfortunately, because we have to solve for the angle, this isn't the easy kind. We have to do this step by step in our calculator. So, now that we've done this a couple of times, I'm going to stop writing it out every single time. You can feel free to do it still, but it's just hard to write out on with a mouse. So 20 squared, and then I'm going to subtract over both of those. So minus 17 squared plus 8 squared. Put that in parentheses. And then once I subtracted the over, I need to divide by this part. So divided by, in parentheses, negative 2 times 17 times 8. And the reason why you need to have this in parentheses is because if you don't, in order of operations in PEMDAS, PEMDAS means that the multiplication and division and the addition and subtraction, they both kind of like, it's whichever one comes first when you're going left to right. So if I didn't have this in parentheses, it would read as the answer, which is 47 divided by negative 2, and then take that answer and multiply it by 17, multiply by 8. We don't want that. We want to divide 47 by all of this stuff. So hit enter. This is what cosine of C is equal to. I don't care what cosine of C is, I just want to know what C is equal to. So second cosine, second answer. The angle C is 99.95, and it wants it to the nearest degree, so C is equal to 100 degrees. Okay? Now that I know that information, it wants me to find the area of the triangle. And the formula with area, you need to know one of the angles. See, area is back over here. Area is 1/2 AB sine C. So we needed to know what one of the angles was. So that's why they asked us to find the angle first. So now I'm going to figure out that part of the problem. So let's see, K, or the area. Now, which two sides am I going to use? Remember that we can only find the area of a triangle if you do side, angle, side. So I need to use the two sides that are right next to this angle. So this is 1/2 8 times 17 sine of 100 degrees. And I'm going to type all of that into my calculator. Whoops. Oh my goodness. Come back. Thank you. Alright. 1/2 times 8 times 17 times sine of 100 degrees. Enter. The area is 66.9669, and it wants it to the nearest integer, so the area is 67, either inches squared or centimeters squared or whatever. Okay? So you might have two-part questions like this that you see on your homework, and I'm going to stop right here and start another one for you.